Okay.
Slides.
Okay, so the slides are online, and so if something is wrong, you cannot read them. You can get them from that URL there, but you can also probably download them from the SCAD website. I just uploaded a PDF there. So the talk today is overloading PerlOps using Access. But first, a small introduction about myself.
I have been, before you start your talk, I have been ordered to give an announcement, which is, please make announcement for this talk. If you have a question for Larry Wall, send out a tweet to #DCPIP, #AskLarry, and we might include your question in the Q&A session this afternoon. You may proceed.
Okay. So, quick introduction. I'm Nicolas. I'm also known online as Atomic on Twitter, GitHub, and also cPan. I'm working for cPanel, and we're always looking to add new talent to our team. But the talk today is overloading PerlOps using Access. So let's focus a little on the title. We can probably cut that part in 3 pieces. That's what we're going to do during that presentation there. So first, overloading, then PerlOps, and then Access. Okay, so overloading is probably one of the most common techniques you are using while you are testing. It's also known as mocking. Most of the time, the easiest way to mock a function is probably to simply overwrite the sub like this, for example. Or we're using more and more the TASMAC module, which provide a very nice function which was added recently, I think over the last year, named redefine, which we simply croak if you try to define a function that doesn't exist. And it also takes into account the inheritance, the either thing. So you can redefine a function that's only defined by one of your parents. Okay, that's overloading. PerlOps, it's something else. Here I'm showing a simple extract of what we can name a PerlOps tree. Okay? So that's probably obscure for many of you. We'll try to make that thing less obscure. This is a simple program, A equals B plus a number. And we are just using one of the B module here, TERS, to show us the execution order of the op tree. So I also stripped some useless information for us there. But what we can see is we have some op, cop, SV op, bin op, and we have some value on the side. Mainly we are pushing on the stash B, the integer 42. Then we are calling the add function, and we are going to assign it to the stash, to the SV slot in the stash A. Okay. So there is more than one way to print a op tree. You can also use concise, which will give you much more valuable information. And here the op are buried in the character inside the bracket. There is a mapping of every letter which correspond to one op. So this is exactly the same thing, and we can see the same. So for the purpose of that talk, I will mainly focus on a single hop. On the easiest one from the Perl source code is the reference op, named refgen. So here the simple code is just backslash and $f, and we're just going to focus on backslash, which is, in that case, refgen. So we have the F GV there on the stack, and we're just asking the srefgen. So, but there is more than one op in Perl. And these change over version, over time. Some of them are there for very, very long time and they will probably not move, but every op mainly has a mapping to an integer. It's a one enum in C. And what you always have the maximum value at the end, so you are sure to always stay in that valid range there. But you have many op. If you continue digging inside the Perl source code, what you could find is all these op, they have a name. Okay, they have one integer value, but they also have a name, and that name is stored in one global list named PLOP name. So you can see all the name of the op there, and you will also discover that there is another list named PLPP at ADDR that also contain, in fact, a pointer to a function, but something named Perl_pp_ the name of the op. Okay, so what is Perl PP GV or G element? This is the up function that's going to be executed when you are going to run that up. Why PP? Mainly because you are pushing some value from the stack and then you are putting them back for most cases. So it's a push-pop operation on the stack. If you grep where are these PP defined, they are, first if you grep for Perl underscore PP, you will not find them. Why? Because you have a macro named PP, and everyone is using that macro to define one up. You are not required to, you can do it manually, but everyone using, by convention, is using that macro. So that PP underscore apps is going to define the apps. So that will create a function named Perl underscore PP underscore apps. Okay. So here I'm showing like a few of them in the pp.c where they are defined. But what you can see is that they are not only defined in pp.c. Some older C file define some different ops for different behaviors. So we also have ppsys, ppot, and we're going to also later focus on one of the ppsys one. So if we go back, if we sum up all of this, if we use concise on \$f, we can see our srefgen up, which has its own code defined as 20. We have one function for the srefgen defined like this, and that function is then going to be plugged into the 20th slot of that array. So we'll be able to call it later at runtime. So here is the code for the up / to get a reference on something. Mainly you get a pointer on your stack, and you create a reference SVRV to that stack pointer, and you store it back to the stack, and then you can return. That's the easiest op you can find in Perl. I could not find any more simpler than this. So this is the op. You have then every op will just do take input on the stack, play with it, and then return one or more, and sometimes none. Okay. So we have seen what's now overloading PerlOps, but XS. In fact, we just saw XS, but probably we should see a little more than this. But why are we overloading PerlOps using XS? Why should you do that? Because SumUp, like die is one up also, that's probably one of the most common ones you are using. You can simply override it using global core die and set your own custom function there, and that would work. You are overwriting the ops, you don't need XS for that. So here's one attempt. For example, I set a function to overwrite die, saying, hey, do not die, I'm still alive. But the problem is if I run die here, you can see if I run that program, I'm clearly going to die. Why? Does someone, I probably someone know. But the obvious reason is the op tree was already built when I defined that function. If I check the op tree, the only line that matters there when I depart this is that I can see my op here die, which is going to take, this is the end of the stack. That op is going to be executed there. I'm going to clearly die. That's the goal of the op. So how do I solve that? To solve this, mainly, you overwrite that function at compile time. So now it works. Just adding a begin block around that overload or mocking will now make your code continue. The die is not dying, just says still alive, and you're reaching the or not line. And if we investigate what looks like the op tree, we can now see that the op tree is going also to take, or this is the on string there, but going to pass it to that CV there. and not our op anymore. So why should you use XS to overload op? Because in some case, and this is one of them, I don't know, and I think it's not possible to overload that kind of Perl op using non-XS. How do you during your unit test, how do you mock -E, -F, or whatever? So if you check -E is defined as one op. Does this file exist mainly? Op ft is. And we have everything well. So we have the name with the code 275, we have the function defined, and this is plugged in the PLPP editor. So probably now let's try to dig into more XS code. Time for a demo. It's not really a demo, it's more, so I don't know it will render there. So we're just going to go to view. So this is a branch of the OverloadFileCheck module named demo for the purpose of today that was oversimplified to show you how we do this using XS. And I'm only going to focus on -E on the minimal thing. So can you read it? Okay. So this is a PM file. That PM file just say, hey, I've got one XS file, please load it. So far easy, okay? So I've got one XS file and load it. And what we want to do, we want to provide a custom API where we can say, please mock -E and please stop mocking -E. So we will have a function named mockFileCheck that will take a type as first argument, and then a custom function, which means our user could use Pure Perl to mock that -E behavior. So -check is there, the sub is there. What we are going to do, we are going first to check if it's a non-type, like if -E is known. If it's known, then we're going to get its op number. And if that's the case, the sub we have there, we are going to store it in one local hash that was just defined above. Okay, so we store that sub. It could be an array also, because that op type is a number. And we are going to call our XS function, say, hey, I want to mock -E. That's what that function does. Same thing for unmock. You unmock it, you don't need to provide a function there, but mainly you just check if you have something defined in your hash. If you have it, you delete it. In that case, you just trigger the XS code to say, I want to stop mocking that function. Okay? That's all we have there. And then later at runtime, when we're going to run -E on the XS code, we say, oh, -E is mocked. The XS code will trigger that check function, come there with some arguments, saying the op type on the file or any other arguments, and that function will take care of calling our mock function and return it. And the cool thing is, I think it's always a very good habit to use constant. When you start returning 1, 2, 3, 4, 5, 6 or more from your function, using constant is always a very good behavior because at least it's human readable and you are not losing any performance doing this. So this is what's doing there. So we have a few constant like check is full, check is true, fallback to real op. So that's all for our Perl file. Now go back, let's check our XS code. Okay, when you start reading one XS code, what I usually do, I go at the end and check the boot. The boot is what's happening when you load your XS file. So mainly what it does there, it just creates, it allocates a memory for that struct that's defined somewhere else, where we're going to store our boolean to know if the op is defined, is mock or not. It gets a pointer to the stash, to OverloadFileCheck, which is where every element are stored in that package namespace. Mainly it's a hash for that namespace. And we're going then to define some constant. This is our check is true, check is false. Okay. And the cool thing is, for example, we're also going to recycle the SV yes, SV no value. And we're going to use the fallback to will op. So we're just defining some constant. Okay. And what we are doing there is at boot time, we are going to say, I want to initialize the mock of a file check, name op ft is, which the with the code of ft is. So that's the enum in C. That's a number there. And I'm going for this op, I'm going to use that helper as my custom overload, mainly because that function is mainly returning yes or no. Some other check like -s will not return only yes or no. Okay, so you probably wonder what looks like that function. It's a macro, so mainly everything you do in Perl is macro, macro, and macro, and you're learning macro. This is cool. So that macro, what's going to do, it's going first to create a new const into the stash. So the stash is coming from above, it's not clean, but the stash is coming from what was accessed at boot time. Mainly we're saying the string of ft is as for value this one, because every Perl version could have different values, so you don't want to care about this. And so it's better than XS automatically advertise it to your Pure Perl program. And then this is our structure that we just malloc above. What we are going to say there, we are going to say two things. We are going first to save the real value of the original op, which is saved in PLPP there. We are going to save it into that slot there. What's the real pointer to that function? We are going to say that by default, that op is not mocked, it's false. That's all we do at boot time. So now, when we're going to use that program, we're going to say, hey, mock-e or do not mock-e. When we're going to mock-e, we're mainly going to use what we saw earlier, the XS mock-up or XS unmock-up. That will just flip a bit in that structure. And the bit flipping is just there. So is it mocked, yes or no? There. What's cool is later, when we are going to call that, we are going to trigger our yes, no custom op in one way, which is defined just there. It's very simple to read, only a few lines, not really, just one more line than what we can read on the slide there. So same thing, macro, and it's dirty macro because that macro can return on your back. Okay, mainly just say, if that op is not mocked, just return on abort. I let Perl handle that. But if that op is mocked, then I want to call the custom user function, check its return value, and depending on its return value, I want to return yes, undef, or something else. In any case, so if we then always fall back to the real op. So that was just a quick example, and that branch is running as some basic test. You can play with it. That's how -e, very basic -e is implemented. So now, how would this look like? We need to continue. Because we don't have only -e, we have many other dash defined in, by Perl. They are all there. You can just run Perl doc, you will have all of them. So, but some of them are returning Boolean on integer value, other are returning, are using stat, and some other are using returning, they are not consistent. So you need different type of mocking for all of them. On the other thing, you have that underscore. It's very, usually it's a good practice which you do -e and -d on the same file, rather than reusing the same name, you use underscore, which avoid to call an extra stat call. So we'll also need to support that. The basic code I show you is not supporting that. The final code on cpan is doing that. So we have bonus slide, or should I say probably the talk is now starting. And we have time. That's cool. So same thing. So now these slides are there. I'm going to make them nicer. Okay. So you have a code. That code does somewhere a -e. Okay. It's just going to say true or false, mainly if the file exists, if the /any path exists. So with what we So is we can say, I want to mock the FileCheck -e with my custom option, my custom function. If that file is any path, I want to say it exists, whereas it doesn't exist on the file system. Otherwise, if it's not that file, I don't know, and I let PerlOps answer that for me. So what you can check is, so these tests are parsing. I have pretty no time to run them. There's no value there. But so now if I do something, I got something, which means the file /any path exists where it doesn't exist on my system. And if I could unmock the -e, now suddenly it doesn't exist anymore. So I trick Perl-E. So, but if I trick Perl-E, that probably means I can do more than -e, and I can do some nasty thing. Because, for example, here, so this is before mocking anything, okay, at startup. Any path doesn't exist, it's not a file, not a directory, not there, okay? And I'm going to call the -e mock with my function, and the -e will say, okay, -e exists, but not a directory, not a file. But now if I use the same trick on the -d, I can say, okay, it exists and it's a directory. Cool, very cool. But I can also go further, I can also trick the system and say, hey, this is a directory, but it's also a file. So I can do some nasty thing that you probably don't want to do, but you are mocking them, so why not? Okay, and that's the function I'm using to mock. Mainly if it's /any path, it's true, otherwise I don't know. Cool. So we saw the first problem of that. Okay. That one. Okay. So that one shows also that the function you are mocking, -check, take the first argument is the check. Here you are only concerned about mocking the DEF. Okay, so otherwise you are going to fall back. And if it's DEF, so you can say, oh, but if it's a directory, by the way, it's not true. So you can slightly massage the thing like this to make it better, but still not perfect. Okay? So what you really want, in fact, is okay, before that, you yeah. So this is just a slide showing that the underscore works because the way it works in XS mainly is if you see def-gv, you just fall back to Perl because during the first call you have filled the stat SV that contain the value of the previous system stat. Okay. So here, your custom function, in that case, will only be called once, only for the -e. For the -f, it will trust on the value you have returned. Okay, but this is not enough. So what we need to do mainly, we need to provide stat. Okay, because what the system does when you do a -e, -f, it does a system call to stat to check what the stat of that file. So the idea is provide your own custom stat on a file and then use that for any other -x check. And to do that, the module is providing some helpers. So if I go back there, mainly, so I'm mocking the stat. So instead of having -e or -f there, I will mainly have stat or lstat, depending on what call is performed. And I can return either an array ref here, either as a hash ref using these keys, either I can use some helpers provided by the module, say, oh, this is a directory, or this is a directory, but by the way, it's owned by root and was created at that time, and so on. Or this is a file, this is a symlink, this is a socket. So you have some helpers that will avoid you to burn your head and find which bit you need to set everywhere. Okay? And the magic occurs now because you have that function here named, I want to mock everything using my fake stat function. So you just provide a fake stat function, and then your, so here it's not mocked. No, this is mocked, yeah. We're mocking, we're using stat as null file, which means our mock function will behave like it's a null file, and we can check that we have a null file, the dash s on underscore returns 0, the dash z is true, and null file is mainly there. Just say, if it's a null file, return stat as file. And the other flavors of that mock function is, if the file is not null, okay, mock it as a file, but its size is something. Okay, so 98765. And if I say I want to mock it as a non-null file, then now if I do a dash s on either my custom path or the underscore, which is the same, I've got that size there, and it's a non-null file. So that's cool. So we can easily mock all these things using stat. Using that module, Todd Rinaldo, available there, showed yesterday an addition on it, which is TASMAC file, which its goal is mainly providing a mock file system. One of the interests of that is if you have concurrency and many unit test concurrency, you could simply avoid conflict between your tests, okay? And say, oh, for example, the passwd file exists and this is the content, do not mess with it. But the best feature is providing is the strict mode. And if you have missed this talk, it's free online, or it will be online pretty soon. But the strict mode is one of very cool feature, because that's a crash if you are trying to access a file that is unmocked. However, it can be open, it can be opened here, it can be a -e, it can be anything. If you try to access a file from that test and you don't, because it's very common that somewhere very deep in your stack, something is going to access the file, you're going to crash or you're going to have conflict. So, still a work in progress, but pretty, we're using it pretty well. So the lesson learned from this is first better knowledge of the PerlOps, okay? So you can mock a file system for testing using the TestMock file module. Oops. Ooh. Where's my mouse? Oh, nice. Okay. 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 I need to step back. Okay. So you can mock the file system. Having that knowledge also helps us to improve the Perl compiler by coming with some ID like lazy ops, lazy regex, but also some future improvement for Perl itself that we are going to come in the next whatever sprints. And one of them is improving the way CV and CV for XS works to speed them. Rennie already did some experimental work on that. That looks very promising, and so on. So I hope it gives you a better insight of PerlOps on maybe XS. You can find all these slides online. And yeah, thank you for coming. Any question?
So was that big stat doing both the stat and the lstat, or caching both?
You can mock one or the other or both, because yeah, with stats it will mock everything, stat on lstat. But yeah, when you say mock from stat, it will do both.
Are stacked file tests the same ops as individual file ops, or file tests? So -e-f file name, is that the same as -e file name, -f file name in the op tree?
-e-f file name.
Yeah, because you can now stack. So is it the same ops in
What are you saying when you're using underscore? When you're using file name?
So what dash E space dash F space file name, that maps to,
Okay.
logically, I don't know what it does in the object, but logically that maps to dash E
I think it's
file name.
exactly the same as doing dash F the file, space dash E underscore. Because you are providing no argument to the other, which is at underscore mainly. So you are doing only one stat call. So
Yeah, okay, but I'm asking if it's the same op. I know it's
two
the same
up.
stack.
It's two up, but they are. It's two different up, but they are probably some of them are sharing some code. Some of them are called with different flavors. So sometimes what you can have one function, and that function will check what is my op ID, and depending on that, it will. You have some shared code, and you have some different if-else branch in the op. But in the op tree, you will see two op.
Okay, yeah, that's why I want to make sure is that it
Yeah,
translates.
you will see two
One-
op,
one
and in the case you
op
did.
ID supports two op codes that are nearly identical, and just checks the incoming opcode type.
So the interface that TASMAC file uses specifically is, it doesn't actually answer dash E questions. It just says, well, here's the stat, and it lets this module figure it out. And then, yeah, it handles all those permutations. And it actually does underscore correctly, specifically.
Yeah.
Yeah, I saw that it helped handle underscore, it was just that weirdness, I didn't know that was a whole new op or if it was
What is that? Is that 526 or 528?
510. It was 591.
I have no idea.
I just looked it up.
Okay. Any other question? Okay.
Are there more than 15 people in the world that understood your talk?
I guess so. I try to. So this is a follow-up on last year. Last year I was introducing basic access. On this year I'm just going one step further. Like me, I keep learning, and this is try to make it accessible. So you need probably some basic knowledge. I guess if you don't know mocking, you start from a very bad step from the beginning. But
Yeah, because the op tree hooking and
on the example, the repo I provided online, I oversimplified it. The number of lines there are pretty small. So if you're interested to dig, I think for someone, it's pretty low cost enter. Okay. Yes.
Can I ask one brief XS question, not specific to mocking? What is PTHX?
The interpreter threads, isn't it?
it's an interpreter instance pointers for threads, so you can have multiple Perl processes within the same physical OS process floating around. It would be like an instance or starting Perl from a shared library, two different shared libraries launch two